Hello and welcome to this course. I am Dr. Sriram Kumar. Today we are going to learn nanomaterial synthesis. When we think about nanomaterials, we can synthesize that materials by two techniques. One is top-down approach and the second is bottom-up approach. So in the top-down approach, we have bulk materials. For example, if we have gold material. For example, we have the sheet of the gold material or the maybe the brick of this gold material. And if you want to make the nanomaterial, gold nanomaterial, so for that we can use top down approach because we have bulk material and we need to break down that material into a smallest particle so that we have finally that material has the dimension from 1 to 100 nanometer. So in the top-down approach, we have different physical methods. For example, we have mechanical milling method, we have laser ablation method, we have sputtering, we have PVD, that is a physical vapor deposition technique. So using this technique, we can decrease particle size from bulk of material to the nanomaterial range. And in the another technique that is the bottom-up approach. So in bottom-up approach, we start the materials growth from the molecular or the atomic level, and that atomic or molecular level of material starts growing. So there is the first growth phase is that the nucleation. So first there is the nucleation happens, and then after there is the growth of these materials. So then after we get the nanomaterial. So in bottom up approach, we start with the building block of that materials. So we have chemical method and biological method. So in bottom up approach, we have chemical method and biological method. So using these two techniques, we can develop nanomaterials. For example, we can use spinning technique, we can use soldier method, we have the laser pyrolysis, we can have this chemical vapor deposition, we have this chemical reduction, green synthesis, maybe the electrochemical deposition. So these are the bottom-up approach in the nanomaterial synthesis and the deposition. So now let's understand in the bottom-up approach and the top-down approach, which kind of techniques we have. So nanomaterial synthesis can be done by the top-down approach or maybe the bottom-up approach. So in the top-down approach, all kind of the physical techniques are in the top-down approach. For example, we can use that mechanical method, for example, ball milling method. We have the second important kind of technique is physical vapor deposition. So this is PVD technique. Lithography, we can use pyrolysis thermal evaporation technique. So in the bottom of approach, we have this two kind of method, that is chemical method and as a biological method. So in the chemical method, we can start from sol gel technique. So using sol gel technique, we can develop nanomaterials. We have another is the chemical vapor deposition. So we start with the vapor of that particular material and then start depositing this material on the substrate. So and there the third technique is the co-precipitations, microemulsions, hydrothermal, sonochemical, and this microwave. So these are very important chemical methods. And in biological method, we can use biological sample. For example, we can use algae, we can use bacteria, fungus, yeast, or maybe this is kind of this bacteria. And using this kind of bacteria, we can develop nanomaterials with this with the same shape or the morphology of this biological sample, and based on that we can have the better activity of these nanomaterials. So here we are going to use biological sample as a template and the grow in nanomaterials. Either we can use the enzymes, maybe we can use the plant extract or maybe the agricultural waste, and using this we can develop nanomaterials. So till now we understand we have this two kind of the approach. One is the top down approach, one is bottom up approach. So in the top down approach we have the physical method. However, in this bottom up approach we have this two method, chemical method and the biological method. So now let's start with the physical method. So first physical method is the mechanical method, that is this ball milling method. So in ball milling methods, this is the, we can say, the simplest techniques to develop or synthesize nanomaterials. So in the ball milling kind of the methods, we have we have the containers. So we have here the container, and the second important entity is this ball here. So here the ball material may be the kind, so that depends on the which kind of the material you want to develop. For example, if you have the soft kind of the material, and if you, for example, you have the carbon materials, so in that case you can have this that ball, maybe that, so that is made of stainless steel, so that is the hardened stainless steel kind of the material. Suppose if you have the really hard material and if you want to make from bulk materials to the nanomaterial, for example, if you have the nickel, if you have this chromium, and if you want to make this nickel chromium to the nanomaterial, and since these are the very hard materials, so in particular case, we can use zirconium oxide based material, because these are the very hard to this kind of material. Or maybe we can use tungsten carbides, titanium carbide, zirconium carbide kind of material, so these are very hard as compared to the nickel or the chromium. So it depends which kind of the material you are going to use. So first important point is the material of this ball, and maybe in other word we can say is the what which kind of this material we can use in the material of the ball, so that we can have the efficient nanomaterial. And the second is about what ratio of the ball and this powder material you should use in that container, so that we will have the nanomaterial. So based on the report, it is 2:1 ratio. So here, the that ratio is the mass of the ball divided by the mass of this powder you want to put in that machine in ball milling take methods, so that you have the efficient formation of the nanomaterial size. So in ball milling methods, we maybe have the three kind of this mill, that is the accelerator's mill, second is the vibratory mill, and the third is planetary mill. So here in so this kind of the techniques differ by how you can use your system. For example, in vibratory mill, you have container and you have this filled with this ball here, and there you have this fine materials inside here. So what happens, so we put the that container in the vibratory table, so because of the vibration, so that will move like this way, and because of this high vibrations levels, so here we have the tiny material, so that will strike together, and that will convert into nanomaterial. However, in third case, that is planetary meal. So in planetary meal, we have states and we have the container there. So it stays moves in the clockwise, and however that container is meant to move in the anti-clockwise. So there is a stage there, so that moves this way, and the container on top of that stage that moves in this way, so that you have the huge collisions between the balls in that container, and some particles maybe collide between that container, and that forms nanomaterial. So these are the working principle of the different kind of the ball milling methods. Now let's understand. You can watch this YouTube short videos as well. That is 2 to 3 minute short video, so you can understand how these mills works and how that collides if that rotate in clockwise and anti-clockwise fashion. Now let's understand what is happening in this ball milling method. So in ball milling method, you have this kind of devices or the stage in which you put your container and the balls. So you have the here. So this is the kind of this container. So you have the container, and in that container you have filled with this. So yeah, these are the ball, and this red one is the other kind of the materials. So if you rotate this kind of the container in clockwise and anti-clockwise, so what happens here is, suppose you have this ball, and so because of the sudden movement in the clockwise, what happens is this ball collides here, or maybe that collides maybe on the surface of the container, or maybe if you have already you have the ball here, so that ball collides with that particular ball. So you already have the ball here, and another ball is coming from this side and colliding to that another side. So what happens if you have this material there between the balls? So in that case, we have this kind of the interactions. So suppose in initial case, so you have that this ball is here. So this one ball is here, and this is the second ball is coming, and if that collides, so second ball is coming and collides. So what happens? So initially, maybe we have the elastic kind of the deformation of the materials, and if later on, if that ball is very close to each other, so in that case, this ball may be deformed plastically. So that means initially plastic deformation happens, and the second stage is about the plastic deformation. So here the plastic deformation means that there is the breakdown of this material. However, in the elastic deformation, no breakdown of the material. However, in the plastic deformation, there is the breakdown of this material. So there is the change in that material's morphology. And then after there is the shear deformation. So once that material is break down in the smallest particle, in that case, that materials combines together, certain tandem materials combines together, and that forms such kind of the morphology, or maybe the desired morphology kind of the things. And there is the fractures, amorphizations, and the chemical reactions happens in that stage, and based on that we get the different kind of the maybe morphology, the particle size distribution, or the maybe uh, activity of this material. So here in the shear deformations, or maybe we understand with the other figure, that in the high energy ball milling, we have this two phase. We can say is the, for example, if you want to make BiVO4, that is very important photoanode material. So this is very important photoanode material. And if you want to dope the copper in this bismuth vanadium material, so for that we need to use the starting material as the bismuth oxide, vanadium oxide, and this copper. And we want to dope that copper metal in that bismuth vanadium material. So for that we take the precursors, that is maybe this material is in powder form, or maybe in digital form. So we put that material in this ball milling container, and we have the balls there here. So if so in initial conditions, what happening here is you have breaking phase. That means you have the bigger material. So there is the starting materials, and because of the shear fractures, these bigger materials becomes the smaller material. So in the breaking phase, you have from bigger material to the smaller material, right? So after many multiple times, so if that bigger materials is break down in the smaller materials, so ultimately we will get the nanomaterials kind of the structures. And we have the second kind of the phase is that's the welding phase, where we have the very small material as particle, so that combines together, and that forms in the nanomaterial range. So from here, very tiny, maybe the molecules, the small molecules ultimately, so that combines together and that forms the nano materials. So that is happening in this welding phase. So we have this two phases. One is the baking phase, and the second is the welding phase. In welding phase, we have this. So here, these big material breaks down into smaller material. That means maybe molecule, and here that combines together and that forms the nano materials. So now let's understand what are the key difference between the normal ball milling method and the high energy ball milling method. So in normal ball milling method, we have this milling time is very less than 1 hour. However, in this high energy ball milling, then we have the very high milling time. So that time may be from 20 to 200 hours. So it depends on what is the hardness of water, how fine you want to material have, or maybe the homogeneity of the material. So it depends on that. This milling time differs. Second is that we will have the nano material here. So sorry, this is that. So that should be the nanometer. It should be also the small n. So it should be the nanomaterials size of the material particle size. And here in the structure chain, so in the normal milling method, there is no structure chain of this material. However, in the high energy ball milling, we have the change in the structure of the starting material. And when compare the chemical reaction, so there is no change in the chemical, so no chemical reactions happens in the smaller ball milling methods. However, there is the chemical reactions happens in the high ball milling technique. And if you want to control the structure of the chemical reactions, for that we need to have the control over the atmosphere. So here in the normal ball milling methods, we don't have the control over the atmosphere. However, in the high energy ball milling method, either we can use that all this milling in this vacuum, or maybe we can put some particular gas. Maybe if you want to make the oxide kind of material, then in that case, we need to have the oxygen. And if you want to use the pure metallic form, in that case, we will have the vacuum, or maybe the argon filled maybe we have the argon filled container. And here we have the another factor, that is temperature. So in normal ball milling, we don't have control over temperature. However, in high energy ball milling technique, we have the temperature variation from liquid nitrogen here so liquid nitrogen from minus 78 degrees Celsius to 700 degrees Celsius. So we can control temperature in that container. And based on that, we will have the different. So if we control the temperature, in that means we are controlling the structure, we are controlling the chemical reactions. And based on that, we will have the desired morphology of the nanomaterial. So this is all about the way we develop nanomaterial, and the simplest way of developing nanomaterial is the ball milling method. In next class, we are also going to learn physical vapor deposition technique and a sputtering technique. And later on, we are also going to learn chemical vapor deposition. Okay, thank you. Thank you very much.